Okay, so here we go. This is day 2, formula for the nth term. First of all, let's review yesterday. Important points that we said is always to ask yourself if the sequence is going up or down. What did you notice about all of the sequences yesterday? What did you notice about all of them yesterday, Liam?
They were all going up by 2.
They weren't all going up by 2 necessarily, but they were all going up.
Oh yeah.
Yes. Today that's going to change. They're not going to all go up. Some of the sequences we're going to look at are going to go down. You always ask yourself by how much, right? So if it was going up by 4, for example, how did that show up in your formula? How did the up by 4 surface in the formula you ended up with? Caitlin?
4n.
Yeah, it was with the variable, right? Because that meant that each time it went up by 4 more, and so then we had the 4n showing up. What's the 4 called when it's multiplied by the n? Just use you for exam time. Daryl?
Coefficient.
Yeah, the coefficient. It was the coefficient of the letter representing the term number. Very good. All right. And then you looked at the starting part of the sequence and how that variable chunk needed to be adjusted in order to get you on track with the first number of the sequence. We're going to do a similar thing today, but first let's just warm up by doing a problem similar to yesterday. I want you and your partner, all right, Caitlin, or if you want Daryl, why don't you slide down a seat? And everyone's got a partner, all right? I want you to warm up by just doing example 1. So figuring out the next couple terms and the formula for the nth term. It's an easy warm up. Okay, so this first sequence was just a warm-up, similar to what you worked on yesterday. You should have asked yourself, does it go up or down? And your answer to that was what, Mikey?
5n.
Or it goes up. Up by how much?
5.
So that gives us a clue that we're looking at multiples of 5, 5 more each time. And how do these numbers compare to the straight multiples of 5, Mikey?
They are the straight multiple.
They are the straight multiples of 5. What was your formula you came up with?
5n.
So every time we take the term number and multiply it by 5, we get the next term in the sequence. 2 times 5 is 10, 3 times 5 is 15. Very good. 5n was the formula for the nth term there. All right, that was good. Now I want you all to copy down sequence 2, example 2. Because something new is going on here, so you want to be paying attention. 57, 52, 47, 42. What's the first thing you notice about this sequence? It's the first thing here. Jack?
It's going down
It's going down. Down this time. By how much, Jack?
by 5.
It's going down by 5 more each time. All right, that's going to impact the formula. That's going to impact the formula. But I don't want to just tell you what to do. I want to see if any of you guys can figure it out. So I'm going to give you about 2 or 3 minutes with your partner to see if you can develop a formula that will give you the right sequence. Just experiment a little bit. Think about this as it's going down instead of up and how that might impact what the formula looks like. All right, so talk to your partner, give a few things a try, and then we'll touch base. All right? So after working for a few minutes, first of all, keep in mind, like the only major difference between this sequence and the ones we looked at before was that instead of this going up by 5, it's going down by 5. Is that where anyone started? And did anyone make any guesses about how that going down by 5 might impact the formula? Caitlin?
So we thought it would be -5 because it's going down. It's +5 and it's going up.
Okay. So, like just a -5 at the end of your formula, or -5n, because it's going down by 5 more each time, right? So it goes down by 5, and then it goes down by 10, and then it goes down by 15, right? So that kind of seems like that might make sense, but and several groups out there decided on the -5n. But then, when you think about -5n, you're like, well, with the first n should give me 57, and when I plug 1 in here, I only end up with -5, and I'm supposed to have 57. Michael?
Well, can I just say our formula?
so what do you think?
Well, ours was -5n plus 52 minus, in parentheses, 5 times 2.
I think it works.
It
So
works.
cool.
Whoa.
All right. That's a little like,
On the neurotic side.
tell me again what you said. -5n what?
-5n plus 52 minus, in parentheses, 2,
We could just
no,
plus 10.
5 times 2.
We could use plus 10 instead of.
Yeah.
Minus what?
Minus 5 times 2.
2 minus 10.
That would be -5n plus 50. Wouldn't this just be -10? So wouldn't this be -5n plus 42?
Actually, I think it would be plus 10.
Yeah.
And 52 plus 10, Daryl?
Our formula is -5n plus 62.
Is that what you're simplified to, guys?
Yeah, I guess.
Mine's
No,
All right, so Daryl says plus 62, -5n plus 62. How did you get to deciding that?
Well, since it was -5 and the new order we get to, well, to 57, we had, we added 5 to make it 0 because it's negative, and then we added the other 40, the other 50.
Okay,
5.
you added 5 to 57 to get the 62. How come? Because it
I
worked?
was just thinking, but
It's correct. Yeah, it works. Let's check it, because in term 1, when we put in our 1, we have -5 times 1 plus 62. So that's -5 plus 62, and you get 57. It works. And we should check something else, and when you do, you'll see that it works. Let's try 4. When we plug in 4, you get -20 plus 62, and you get 42. That works. So it works, but now the question is, how do you come up with that plus 62 part? How does that come from? Here's my advice. Here's my advice. You get the -5n part, right? So what I recommend you do is once you understand, the variable chunk, the -5n, just start with term 1. We know that term 1 is supposed to give us 57, right? But when we plug in a 1 in this variable chunk, we just end up with a -5. So you kind of got to ask yourself, what do I got to add to -5 to get 57? That's 57 plus 5 gives me 62. That should be your formula. Check it in a couple spots. Daryl?
I just added -5 plus 5 to get 0, and then plus another 5 to make 5. And so that was 10, and then I just added the other 52.
To get there. Yeah. So the key is, once you get this piece, then figure out how to get this starting number. Okay? All right, now I think some people have it. I hope working with your partner, you'll all get it. You're going to try the example on the next page and see if you can put it all together. Try that one with your partners. Okay, so you've had a couple minutes to work with your partner on this example. First of all, what do you see the sequence doing? Up or down, and by how much, Logan?
5. Down by 5.
Down by 5. So what are the next two terms here, Mikey?
it's down by 4.
Oh, yeah, it's down by 4, Logan, right?
Oh, yeah. Oopsie.
Whoops.
Oopsie.
I walked right into that with you. Yes,
So it's going down by 4.
yep.
So it would be 37.
What are the next two terms, Mikey?
19 and 15.
19's here. 15 and what? 11. All right. So we know it's going down by 4, so that gives you what part of the formula? What part of the formula does that give you, Mary? Up by 4n or down by 4n? It's going down. So what does that do to your 4n loop? Yeah, it makes it -4n. We're going down by 4. All right, but then we got to get it so that it starts at the right spot, which is 31. Right? So what do you got to add to this to get it to start at the right spot. You gotta add to it. Will? 35. How did you find that, Will? What was your thought process?
I think the easiest way is to make the 4 in front of the end positive and then the reverse number.
Okay, so basically you're saying you're starting like in a hole, right? And so you gotta back yourself up. So if you add that 4 to here, you'll know that 35 is it. So let's test it. When we put in a couple of these numbers, what happens? When we put in 1, does it work out right? Negative 4 times 1 plus 35. Negative 4 plus 35. 31 works. Yay. But you should always test more than one of them, so which other term do you want me to test? Yeah?
4.
4. So then we do negative 4 times 4 plus 35. What should we get out of this if it's correct? What should we get out if it's correct? Liam?
19.
19, right? Because the fourth term is 19. And in fact, we do. So you found the correct formula. Questions? All right, you're going to practice some of these with a partner now.